my first question is, did you ask yourself about how to determine the correct formula of ionic compounds? I have no idea about it. Let's do it. But before getting to this class, you have to know some of the principles. So the first one, let's talk about how the atoms get their stability. For example, here we have sodium atom. Sodium atom has 11 electrons. If you go to the periodic table, you're gonna see you have 11 electrons for a sodium atom. Alright. So if you want to distribute them in the shells, you know the first shell's capacity is 2 electrons, the second shell is 8 electrons, and then we got only 1 electron here. Alright, but according to this atom here, it has 1 electron in its outer shell, and actually this atom is not stable. Okay, what are the ways to be stable? The only way is to be filled outer shell. So we need to fill the third shell by 7 electrons, but actually we don't have 7 electrons to be filled. So the rule says this electron in the outer shell will transfer, alright, and then we got to be something like this. Alright, the electron here in the outer shell transfers to another atom, so we got only 8 electrons in the outer shell of a new sodium atom here. We don't call it a new sodium atom, actually we call it sodium ion because it has a charge. When I say ion, it means the atom that has an equal number of electrons and protons. So sodium ions becomes positively charged, and actually it is stable. Alright, is it the only atom in the world that did there's something here? The answer is no. So let's take another example. What about chlorine atom? Chlorine atom has 17 electrons in its shells. So how to distribute the 17 electrons in the shells? First 2 electrons, 8 electrons, and 7 electrons. If you look to this atom here, the outer shell here is not stable because it has 7 electrons. So it needs only 1 electron to fill its outer shell. So another electron comes from a certain atom that has been lost its electron, and then we got it here. We got chlorine ion, and a chlorine ion as a result of getting 1 electron to the outer shell. So it becomes negatively charged, its outer shell becomes full of electrons, and actually this ion is stable. So what we call the electrons that have been lost or gained, we call them valence electrons. So let's talk about the valence electrons. Valence electrons of group number 1. You know group number 1 like sodium atom that has only 1 electron in its outer shell, so this electron transferred. So the electrons, the valence electrons of a group number 1 is 1. Same for group number 2, because group number 2 will lose 2 electrons. And the same for group number 3 because it will lose 3 electrons. Group number 4 will share electrons, and it's another story. We're going to talk about this later on. And what about group number 5, 6, and 7? If you look to group number 5, its outer shell is filled by 5 electrons, so it needs 3 electrons to fill its outer shell. So the valence electrons are 3. What about the valence electrons of group number 6? So it needs 2 electrons to fill its outer shell. Same for group number 7, which is a chlorine atom that has 7 electrons in its outer shell, and this atom gained 1 electron to be filled. Okay, but why do we need this? What is the relation between the valence electrons and naming of ionic compounds? The answer is coming in its way. So let's take the first example. If I ask you, write the formula of aluminum chloride. You go to the periodic table and then determine the number of electrons for both aluminum, alright, and chlorine atoms. So aluminum from the periodic table, it has 13 electrons. If you look to the electronic distribution, it means it has 3 electrons in its outer shell. So the valence electrons in aluminum atom are 3. Alright, what about the valence electrons of chlorine atom? Chlorine atom has 7 electrons in its outer shell, which means it needs to gain 1 electron. So the valence electrons here is equal to 1. Alright. So we write aluminum symbol, alright, and then we put the valence electrons below. Same for the chlorine atom, and we draw the valence electron below. And then we make a cross multiplication. The cross multiplication indicates you just have 1 aluminum atom and 3 chlorine atoms. So the formula of aluminum chloride becomes like AlCl3. Okay? So let's take another example to enhance our understanding. So let's start with how to write the formula of calcium nitride. Start with a calcium which has 18 electrons. When we distribute the 18 electrons in the shell, the last shell is filled by 2 electrons, so the valence electrons are 2. What about nitride, which is nitrogen? It has 7 electrons. According to the electronic distribution, the outer shell is filled by 5 electrons. The 5 electrons here need 3 electrons to fill the outer shell, so the valence electrons are 3 for nitrogen atom. So we write a calcium symbol here, and then we write the valence electrons below. Same for nitrogen and the valence electrons of nitrogen. We just make a simple multiplication here, cross multiplication, and then we got the formula. So we have 3 calcium atoms combined with 2 nitrogen atoms. And here we have the correct formula of calcium nitride. Let's take another example. Magnesium oxide. We start with magnesium atom here. It has 12 electrons. The outer shell is filled by 2, so the valence electrons are 2. What about oxygen? It has a valence electrons of 2 because it has 6 electrons in the outer shell, and actually it needs 2 electrons to fill its outer shell. We write magnesium atom with its valence electrons. Same for oxygen with its valence electrons, but here the ratio between valence electrons is 1 to 1. So we don't care about the numbers and we write them like MgO. That's fine. Everybody's happy. Thanks a lot, guys, for watching. If you have any questions, you can ask me in the comments below. And thanks a lot.